you do this motion where you take two strands of hair like this, and you divide the hair about evenly, and then you do this motion in order to do the braiding, which is you do this over, and then under, and then over, and then under, and then each time your hands got closer together because the braid was getting shorter, right? Well, if you took the hair out of your hand and instead put a pen in your hand, you would have drawn the frequency signature of the harmonics of the EKG of the heart at the moment of love. And so you can begin to understand kind of mechanically what Glenn Ryan measured in that study, which is how the sounds of your heart mechanically braid your DNA. And so let's take a break and we'll look at some more pictures. So I was fortunate to work with this molecular biologist, PhD, Dr. Adoniah McKenzie from Georgia Tech in Atlanta, Georgia, USA. And she wrote an article saying that with the discovery of recombinant DNA biotechnology, essentially genetic engineering, humanity made off with Mother Nature's scissors. Unfortunately, we know less than she. The part of the article I'd like to discuss here is where she says, quote, "It is assumed that the preponderance of junk DNA that intervenes between coding regions is inefficient, useless, and could be removed for greater streamlining. In actuality, these spans serve multiple biological functions, cancer prevention, gene inductions, and should be left in place within the genome." She then discusses what she calls jumping genes, and that if they genetic engineers attenuate non-coding regions, that is, cut them out, they may increase the likelihood of jumping gene-induced cancer. Well, the article is getting a little bit technical, but very simply, we're beginning to get the sense that we must understand how it is that the mechanical spacing between the gaps in the slinky of your DNA is actually the issue of proper genetic function. And then further in the article, Dr. Adoniah McKenzie goes on to say, and I'll just read this briefly, intervening sequences, introns, can be necessary for effective gene induction. For DNA to be converted to RNA from a coding sequence, an upstream promoter must be induced. And what she further says then basically is that this upstream promoter, this intron, has to find that the space it climbs in the ladder, the mechanical interval, has to be kind of musically right. So the spacing between the rungs of the ladder, even mechanically as it's braided, have so much to do with how groups of genetic material actually are able to do this jumping gene and the work of the introns where they move themselves between groups of codons. So the mechanical position of the groups becomes the issue, which is just what we were saying about braiding. And then at the end of the article, Dr. McKenzie says, and you can read the article again at danwinter.com/magneticx, which is the article that originally helped us work on this piece. In the end of her article, she says, "Oh yes, and by the way, there are magnetic field effects in the genetic material that can't happen if this long wave structural alignment doesn't happen." So she begins to start giving us this clue again that, golly, we need this magnetic field effect in order for DNA to work properly, and the magnetic field effect can't happen without the long wave braiding, and the long wave braiding just simply can't be this embeddable nesting if the genetic engineers keep slicing out little segments of the slinky, not realizing what the long wave is about in DNA. So that brings us to some of the other pictures, which really have to do with, let's see if we can find the pictures here. The one I wanted to show you here, here's the slinky, okay? This is the one where we're showing that the ratio of the diameter of the DNA helix to one full 10-turn ratchet, 20 to 34 angstroms, very closely approaches the golden mean ratio. And further, that, remember when we were talking about the top-down view? Here's another picture of the top-down view. I wanted to play this picture. You see that if you saw the magnetic donuts as a kind of cloud or smoke ring donuts formation, you have this 10-sided view, and then you have this picture from the biophysics literature, if we zoom in right here, we see that each rung of the ladder of DNA is actually based on this accurate 36-degree angle, 1/10 of a circle. 36 degrees is 1/10 of 360. So you have this braiding based on the decagram. Remember we showed this top-down view decagram, this helix? So now we can understand back over here that in this top-down view, maybe if you zoomed in really close here, just right on this part right here, you see that the waves are able to add and multiply as they compress themselves into that nest. And this creates the perfect compression, which is literally happening right in the center of the slinky of your DNA. And this is the issue of the perfect squirt gun, which was back here. Let's see if we can find it. Right here. Here's the squirt gun action. Let's move this. I'm going to move this to center just a little bit. Okay. And you see that now we've got this X right here. Okay. You understand now that you had a braid of the braid of the braid on the braid, and eventually you get this X right here, where many short waves and many long waves cross each other right at the center. And that creates the phenomena of this harmonic cascade right here, which is literally the mouth of the X. That's the magnetic X. And the point is, what we believe is the wave fronts at that point begin adding and multiplying. And I'm moving this again, sorry about that, but I just want you to see the rest of this picture. See how the wave fronts begin adding and multiplying because of the perfect nesting of the wave on the wave. And that's what we believe is literally the implosion, which sends the wavelength through the speed of light at the center of DNA. And there's an animation I'd like to play for you in just a second about that. So here we're actually taking another look at the ratio of the donuts, except all I've done is I've revolved the sine wave in 3D so it looks like a flame or fire. And the ratio between the size of the harmonics is based on the golden ratio, so you get this concrescence, we called it. And you can see how this phi's ray or golden ratio could be almost thought of like fire. And we call this how the grid is ignited, but it's really just how the heart is ignited, how the fire is lit. And this is a little animation we prepared so you see how these heart harmonics become ordered right here. The harmonics become very nested, and that creates a cascade where the frequency signature of the harmonics at the moment of bliss shows that the second order frequency harmonic analysis looks like it's the wave you started with. The wave is in the wave embedded, and the interval between harmonics is golden ratio, as close to 0.618 as we can measure. And that creates this pattern of what's called perfect bifurcation or perfect branching. Okay, this is branching. 1, 2, 3, 5, 8. And the space between the branches is actually based on golden ratio, as is the nesting of the Mandelbrot set of perfect fractality, which is simply perfect embedding or perfect nesting, which we'll see in a minute is the business of perfect turning inside out nest or perfect compression. So bifurcation, or how to divide without dividing, the solution to the problem of separateness is solved by this phyllotaxis of perfect branching. And that creates that perfect spin path into the center, which is that three-dimensional golden mean spiral. And I just want to back this up just a little bit. So you see here that if we take those same 10 spirals of the golden mean, and we had seen them from the top view, it would look exactly like the top-down view of DNA we just saw. Yet, if now we see that revolved from the side view, what those spirals embed, here we've gone 32 degrees, which is from the hex to the pent. We've gone from a 5-sided to a 6-sided view. And if we revolve further now, we see the side view of these two, what look like pine cones right here. And this is a pineal shape. It looks like a pine cone, and it might even be related to perfect, what we call pining or yearning. It looks like a screwing action. And it has embedded this nest of this shape we call the dodecahedron, which is simply a shape which is based entirely on the golden ratio. So it's the beginning of the map to sacred geometry. And we see that is a particular shape which could embed itself one inside each other, just like these perfect little dolls where you see one inside the other. In fact, let's take a look at that in just one second.